with such a receiver, well, which is a transmitter in fact too, you are able to eavesdrop a PCL 900 meters away from the equator. And people who are selling those systems assure you that it's not possible. This is the version 4 of the project, which will be more precise, more dedicated. It's driven with a microcontroller with a very high-end input filter with very precise slope, more than 80 dBs of rejection. And that's what you are obtaining on your computer screen. This is a normal, what we call waterfall spectrum. This is one frequency. You see a Morse CW systems. Here you have TTY telex translation, RY, 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 and those are different modulation. On the lower part, you have an open SDR that you can access online, located at the Twente University in Netherlands. If you want to play, those are here and here vocal communications. Those are pure CW stations, and you can see that all those bands from time to time are completely weak and blind. For this century, from a pure telecommunication point of view, it's Professor Joseph Nicolas. He invented the term software-defined radio. He's a very respected researcher, and he published several communications for the MIT, trying to convince people that it was possible to create infrastructure fully based on software-defined radio. Why? Because with such SDR, as everything is based on software, you can upload software if you want to change, for example, modulation schema or any kind of things. From in less than 2 minutes, you are able to transform a full GSM network in a Tetra or television network. It just needs for you to have access to the configuration port. That's not science fiction. That's a research team. That's one of the many research launched for this one in Europe. This E2R, End-to-End Reconfigurable Network, has been founded by the EEC. Companies like Siemens, Thomson, France Telecom, Deutsche Telekom, and so on have collaborated to this project. This is a pure research project, not an end-user project. But we are beginning to see companies who are offering components of something looking like that. If you are looking, I can send you the URL of this project. If you are looking at this diagram, you see that you have Wi-Fi, well, not exactly Wi-Fi, but Wi-Fi located systems on the same frequency, conversing with backbone and telephone systems and other communication systems. It means with the same technology, you can have a multi-purpose network. And this system is purely software-based. That means if you have one entry point in this network everywhere, you can hack the whole system. Is it realistic to imagine such a network? The answer is yes. Right now, several airport infrastructure is being contacted by manufacturers who are reselling such networks. I can assure you that people involved in the security of those airports are not very hot to adopt this technology. Well, guess why? What could be used with SDR? Well, several things. First, hacking those future networks. That's the way. Using the SDR exactly like Microsoft used and invented the Wii model. That means having a very simple hardware interface and dealing just with software. That means if one guy in the room is able to create a preprocessor Metasploit, I will be very happy to interface it with my hardware. If you can conceive something able to pre-process signal, because from an electronic point of view, I am able to give to the processor information like what is the frequency, what kind of modulation I have. Even if I don't understand it, I can give the IQ signal. And if something like a parser is able to give me help on how to decode the signal, I can have the pure hardware equivalent of Wireshark, but adapted to every wireless systems. There are limitations. Limitations are, right now, the bandwidth I am able to cover. The technology you saw as one limitation is the local oscillator should be approximately 4 times the receiving frequency. That means if you are trying to